All right, hello. Thanks for attending. I'm Nathan Heldt from Intel Corporation. I'm the OSWG Security Task Group Chair, and I'm here to sort of talk you through the security architecture and a little bit about the IoTivity security layer implementation. My goal is that you come away with an understanding of sort of how we've approached security using a resource model and are comfortable with configuring security on your devices to some extent. There's going to be a lot more behind the scenes that I've sort of described in slides toward the end and further reading material. There's more than we can cover here today, obviously, but I think if you get the basic idea of the resources involved and then sort of which ones you'll need to touch in order to configure your device, it'll help you get off the ground. So I think really there are two functions for the security layer in IoTivity and in OCF. We've got basically onboarding the device, which means taking a new device and joining it to your OCF network and then configuring it for use. So whatever else you need to do to the device to set it up so it can be used to serve up its normal resources. So that onboarding or pairing step is handled by the security layer. And then we have access control, which is basically taking requests that come into the device and deciding whether to service them or not. In OCF, it's a dual-step process where we authenticate the requesting device and then authorize that device to make the request. But for those who are not particularly caring about exactly how security works, you can just think of it as access control. It's kind of lumped together. And the way that OCF decided to implement this or to architect this is to describe a set of security resources that handle the configuration and management of the security interfaces on the device. So those security resources, there are I think about 9 in the specification, but we're going to really talk only about 4 of them today. With those 4 understood, you can really get most of the way, or really all of the way that you need to from a vendor standpoint. If you were trying to implement this from the ground up, of course, you'd have to read the spec and understand the rest of the resources. So the very first one to understand is the device owner transfer method resource, the doxim resource. This is basically the interface that you use to take ownership of the device when it's a new and out of box. The provisioning status resource is next. Once you've taken ownership of the device and you are now sort of in control and the admin of that device, you provision the device with a few things, namely the access control list, which is done through the access control list resource, and the credentials, which are done through the credential resource. Once you've moved the device through the provisioning steps needed, you can use the provisioning status resource to tell the device that it's ready to begin normal operation, ready to start servicing requests for the resources that are hosted in your application. I think worth noting is that because when you open up the JSON descriptions of these resources for your device, you'll see that there are quite a few properties for them, one of which is the resource owner. That's a pivotal one to pay attention to. The resource owner describes the client device, which has sort of intrinsic permissions to modify that resource. So I'll show you in each resource that there's an R owner, or it's actually called R owner UUID because it's the UUID of the owner. But that owner has privileges to access and configure that resource, and normally those configuration resources are owned and controlled by the onboarding tool, the client application that takes the device from out of box into owned, provisions it, and sets it up for use on the network. So a little bit of detail on doxim. And you don't need to try to memorize this. This is just giving you an idea so that when you go look at it yourself, you'll have a better understanding. But basically, we have a property which enumerates the onboarding methods that the device supports. We have a property which selects which of those methods to use. We have the ID of this device. So the device UUID is the ID of the device that this file is on, that this resource is on. And then the ROUUID, as I mentioned earlier, is the owner, the ID of the owner of this device. PSTAT has a few properties which I'm not showing, but the one that's really relevant for security purposes is that the device onboarding state. This is basically a state resource that shows you where in the onboarding and provisioning process you are, and there are really just a couple meaningful states. There is ready for owner transfer, which is sort of out of box, and then you move it to ready for provisioning when you've taken ownership of it and are ready to provision the access control and credential resources. And then there's ready for normal operation, which tells you the device is ready to start servicing requests for the application resources. And again, ROUUID. So I think the most important resource for vendors trying to build a new device to understand from a security perspective is the access control resource. So we'll spend a little bit of time on this one. The access control list you can think of as an array of entries that grant access to one or more requests each, one or more request types each. And the important thing to understand is if there's not an access control entry granting a request, that request is denied. So we have a permission-based access control model that says you must explicitly grant access to a resource request in order for that resource request not to be denied by default. The reason that's going to come up and bite you is that if you build a new device and you introduce a new resource and you haven't configured the access control layer to grant access to that resource, you're going to find that your resource is inaccessible and probably end up emailing activity dev, which we get a lot of those. But hopefully, we're moving towards some examples that show a little simpler way to bring your new device online and have some built-in access control entries that probably suit the needs of 90% of device vendors. It's a balancing act when we introduce examples because we don't want to just try to give blanket access in our examples to make it easier for developers trying to build their first device, because then people end up taking that blanket access policy and just moving it out to a product, which probably leaves things wider open than you want to. On the other hand, if we ratchet things down too much, people are frustrated because they can't get access to their resources. So configuring ACL2 is a thing that is actually probably important enough that each vendor should take some time to look at this particular resource, either in this slide or in the example applications, and get to know it. I'll go through this one example just to give you an idea of what an access control entry can do. This access control entry has a subject, which is the requesters to which this access control entry applies. And that subject in this case is actually a connection type. And I use this example because nominally it would just be a UUID and show you the UUID of the device that you're granting access to with this ACE. We call access control entries ACEs. With this ACE, if you had a UUID, it would just be applying only to requests from that requester. But in order to make the access control list more compact, we've defined some sets of wildcards which apply to multiple requesters and also which apply to multiple resources. So this one is a wildcard that applies to any requester whose connection type is plain text, that is COAP, as opposed to COAP-S. So if you're not connecting over a TLS session, if you're connecting instead just through COAP, you will match this ACE, regardless of your UUID, regardless of which device you are, okay? So in reality, this is a fairly dangerous ACE to use for any sensitive resource. You would only want to use this to apply to resources that you really mean to give access to the whole world to, okay? We have another couple important wildcard types for subject. I think the most interesting one besides a non-clear is auth crypt, which is basically the flip of a non-clear. It applies to any requester that is connecting over a secure channel, over COAP-S. So it's been authenticated and the traffic across that channel is encrypted. And that's a useful one too, and you'll see it in a lot of the examples in Activity and Activity Lite. So the next entry that's important is resources. Of course, this is the resources to which this ACE applies. So you can list each resource individually, or you can use wildcards again. There are some wildcards defined in the OCF 1.3 specification, which is the basis for the version you'll be using in the hackathon. I would encourage you to take a look at those and then not use them. We've defined a much better set of wildcards in the next forthcoming OCF specification, and it makes them usable without giving undue exposure to the resources on the platform. So you can use them, and in fact, in the hackathon basis application that you'll be starting with, we've introduced an ACE that does grant access, sort of blanket access to the resources on the device to save you the steps of having to change and recompile your JSON. But in a real-world product, you wouldn't want to ship a device that grants blanket access because you would then be granting access to the SVRs, which is a bad thing. So you'll see that in the example you're using today, and in 1.3 devices, it's an unsafe wildcard to use. It's important to know. If you come, for example, to certify and that wildcard is on your device, it'll likely fail. But we have introduced better wildcards that you can use to compact the list from a resource perspective without giving access to the security virtual resources in the next version of the spec. And then finally, the permissions, which is a typical CRUD permissions set of bits. Okay, so that's access control list resource. The credential resource is another interesting one. It talks about the credentials on the device that can be used to connect to other devices. So for the authentication step, when you're doing a TLS handshake, the credential resource is referenced by the server device to retrieve the credentials necessary to create that TLS session. I think I've given you a lot of information already about access control layer and the ACL2 resource, so I don't want to overwrite that information with trying to give you a bunch of information about credentials. But suffice to say, if the endpoint that you're connecting to, a client device making requests, doesn't have a credential entry in your cred resource, or in the case of certificate-based authentication, a root cert installed on the device so that it can verify the certificate presented by the client, you won't be able to establish that TLS session to connect. So if you find yourself in a situation where your device is refusing to connect over TLS, or in other words, if you're not able to access any of the resources over CoAP-S, think about access control list and also make sure that you have a credential installed that will allow the two devices to handshake. Okay, so I won't go into more than that on the credential resource. So onboarding methods is an important decision you make when you decide how to productize your OCF device. There are a few methods used to pair a device to the network, similar to Bluetooth or any other protocol out there where you have to take a device and a variety of devices are joined to the network. Some of these devices are completely headless. You just power them on and you need to be able to join them to the network. Other devices have a little bit of user interface, maybe a single hardware button to begin pairing, similar to a Bluetooth device where you hold the button, or an Xbox controller where you press the small pairing button, whatever. There's another class of devices that might have even more user interface available, such as a display where you could enter a PIN or scan a QR code. So because of the variety of devices out there, we've defined a few different onboarding methods which the vendor deploying the device needs to decide amongst and decide which of these should be supported on the device. And there are a few trade-offs among them, and I'll talk about those in a second. But basically, it's important to know that the onboarding method is what takes you from that out-of-box state, ready for onboarding, to the owned state, the ready for provisioning state. It's not the entire sequence that gets you ready for normal operation. It's just that step for doing the initial pairing of the device. And that's why in this diagram it shows this nominal flow through OTM, out-of-box into ready for provisioning, and then ready for normal operation. And that in between those first two steps is where this OTM is taking place. The OTMs that we've defined in the specification currently are just works, random PIN, and certificate-based. In JustWorks, you have a really low-touch experience where the two devices can quietly handshake, discover that the device isn't yet owned, and take ownership of it without any user interaction. The drawback to this particular OTM is that if there is a malicious man in the middle on the local network which is being used to do this onboarding step, that malicious man in the middle can successfully steal the device. So if you've got someone who's set a malware up on one of your devices on the Wi-Fi in your home, and it's sitting there scanning constantly for new devices that come out of box, if it's there at the right time when you unbox your new device, it can man in the middle and take control of that device. So pros and cons. If that's a concern for the networks in which you imagine your device will be deployed, we don't recommend using JustWorks. But if it's not, and if you really want the benefit of having zero user interaction without having certificate capabilities in the device, JustWorks might be a viable choice. The next one is random PIN, and in that one, there is basically a mitigation for the man-in-the-middle attack, which is to have the user or network owner who's doing the onboarding enter a PIN to verify physical proximity to the device being onboarded. Of course, the man-in-the-middle won't have that PIN, and so man-in-the-middle attack is thwarted by that step, but it does entail some additional user interaction. And finally, the certificate OTM, which is really the preferred OTM for a lot of reasons, but it does require certificate capabilities in the device. So that's slightly more functionality than is required in a, for example, JustWorks device. It's important to understand that certificate onboarding doesn't require you to go get a VeriSign certificate or something from a CA out there. Really, it can be an asymmetric credential produced using a command line tool on your own onboarding tool. So don't confuse certificates with PKI necessarily. It can mean PKI. You can certainly use a PKI-backed certificate, but you can also roll your own, which is to say you can use certificate-based OTMs without incurring the cost of a CA-issued cert. Okay? Important thing to know when you're choosing. The rest of the slides contain sort of a sequence diagram which shows an incomplete illustration of the onboarding steps in sequence. This will help you in debugging if you're ever looking at onboarding and are having troubles. So you can refer to that. There's a walkthrough of processing a request with access control applied that shows the access control resource that I talked about earlier being applied in action. But basically what happens is a client makes a request, it arrives it arrives on the server device. That either arrives over a secure connection, a DTLS session over CoAP-S, or an unsecure connection. And at that point, the request has arrived at the access control layer, and the access control layer refers to the ACL2 resource. And if it finds a matching ACE, it grants the request and passes it on to the resources layer. If it doesn't find a matching access control entry, it rejects the request. So there's a sequence diagram that shows the details of that process, that flow. There's also a slide that I think will be very important for anyone who wants to change the access control policies on a device, which is basically a reference to an example JSON, which depicts all of the security virtual resources in JSON form, and pointers to tools and entries in the wiki that describe for you how to take that access control list and other security virtual resources in the JSON and turn it into a DAP file that can be used by activity. So again, there's a slide that refers to examples that will be very interesting for you to look at if you want to change your access control policy. And then there are a few backup slides with additional reading materials. That's all I've got to say about security. Again, I think our packages that we're setting up with today don't require you to go modify those resources in order to get things off the ground, but you'll definitely need to understand them if you want to take it any further than that. Thanks a lot for your time.